Hi, in this video I will show you how to use POM to solve the graphic problem that I have demonstrated for you in several videos so far. I will also very briefly show you an interpretation of the outputs. So here's the problem. We have a max problem, as you remember, and we have four constraints. The second constraint has decision variables in the right-hand side, but we rewrote that so that it would have a constant in the right-hand side. POM requires only positive constants in the right-hand side. And 0 is considered to satisfy that requirement. So you go to POM if I've already launched it. I go to File, New. Oops, sorry. I need to first go to Module and select Linear Programming, if I can find it here. Where is Linear Programming? Oh, there it is. Linear Programming. And then I go to File, New. I will call this the graphic demo problem. And I have four constraints. Remember that the non-negativity constraints do not need to be entered into POM. So I have four constraints, and I have two decision variables, x and y. So I will keep the default. You can also highlight these the number of constraints and variables, and input anything that you like. But in this case, I have four constraints. The objective function, the default is maximization, which is what I have. So I will keep it as that. I will click OK. In the next window, I will make these a little smaller so we can see more on my screen. Okay, so x1 is the first decision variable. The default by POM is to give x1, x2, x3 as the decision variables. So I'm going to change that to x. And I will change the second variable to y. For my maximization, remember I have 10x and 13y. So under x, I will put 10 and I will put 13. I'm just going to go down the column and enter these coefficients for x. In the first constraint, I have 3. In the second constraint, I have 2.4. Third constraint, x has a 1. This is essentially 1x, if you will. And this is essentially 1y, if you will. And y does not appear in the fourth constraint, therefore I will keep the 0 as its coefficient. For the second variable, my coefficient in the first constraint is 5 right here. So I'm going to put 5 and then a negative 0.6 and 0 for y. And in the fourth constraint, I will put a 1. The third constraint gets a 0 because the third constraint does not have y in its formulation. The signs are all less than or equal to, except for the second constraint right here. So I'm going to click on that cell, click the arrow down button, and choose greater than. My right-hand sides are 30, 0, 5, and 4. Notice that I can also rewrite the constraints. I can call this constraint 1, constraint 2, constraint 3, and constraint 4. But these could be something that would make sense. For example, in a problem that you're studying, it could be budget. The second one could be some marketing requirement. The third one could be order, number of orders, units to produce, or whatever. Okay, so with that, I can click Solve now. And you will see several windows, results windows will appear. The first one that pops up, which is this one right here, is the linear programming results. Based on this, you will see that the numbers in black is what I entered. It's my input into the software. The solution, it says right here, the value for X, optimal value for X, you will see is 5. Optimal value for Y, you will see is 3. And the optimal solution for the objective function is 89, meaning that the maximized value of the objective function is 89. These numbers right here are the dual values for each of the constraints. If we go to Window and go to the ranging, you will see another window that also reports the 5 and the 3 for values of the variables X and Y right here. But it also gives us reduced cost, the original value, which were the objective function coefficients right here, 10 and 13 that we entered for the decision variable. So that's what the original values are. And then we have a lower bound and an upper bound. These are called the range of optimality. And then we also have for constraint section of the ranging window, we have dual values, which if you remember, these numbers were reported over here. But these numbers are the dual values. These are essentially for one more unit of each of these constraints, how much will our objective function improve in value. And that's what those are. Also the slack is reported here, here, and here. For constraint 2, because its sign was greater than, if you remember, we call this a surplus. So this is right here. Our right hand side was 0, but if we plug the 10 and the 13 in this constraint, I'm sorry, not the 10 and the 13th, but the 5 and the 3, the optimal solution. If we plug that into our second constraint, which if you recall was this one, if we plug 3 and 5 for X and Y, then our right hand side will be 10.2. So we go 10.2 units higher than the right hand side, which was 0. Full explanation and interpretation will be part of chapter 3. I encourage you in that chapter to study some handouts that I have, which are called LP1 through LP6. And those are part of the sensitivity analysis and interpretation of the computer solutions. Thank you.